Hello, my name is Chris Burke, and this is an introduction to my final project for MET411 finite element analysis. So before we get to the problem itself, I'd like to give a very short background on myself. I'm currently employed as a staking engineer for Clark County REMC, and amongst other things, one of my primary roles is designing overhead lines. So this is a subject that I'm quite familiar in. So recently I took a trip out west to California with my family, and when I was out there I noticed this power line right here. This is what we would consider an atypical overhead line design solution. So if you were to look at it from an overhead view, what you have is a pole and a cantilevered overhead structure to try and reduce line angle. The lines would come in like this. This is your pole. These would be the two cross arms. They come out. And this is your power line. This is a unique solution. What it does is it allows you to have a much smaller lead on your anchor that would come off of this pole to help combat the tension that would be in your conductor here. Typically what you'd find for a situation like this is a pole with two central cross arms. You'd have your angle coming in like this, and you can tell from this representation that you've got a much steeper angle here. So what it would require is a longer lead on your anchors, which would come off the pole down through here to help combat the tension and the greater angle. And the reason they chose this solution right here is because it's in a city, and if you had your typical overhead structure, it would require you to have an anchor guy that goes all the way back into these houses, and that's not ideal. So before we can make improvements to the existing structure, what we need to do is model it in CAD and perform stress testing on the current design. After this was completed, you can see that there was an average max stress of roughly 17,000 psi, and you can see this is a CAD model of the existing structure, and this is a plot of the data. Moving on, the design that I came up with can be seen here. What it does is it changes you from having a truss member that connects to the pole below the frame itself, and it includes a member in tension here, and additionally up here at this pin connection between the cross member and this truss, you have a slightly thicker diameter bolt, because that would be what you would consider the main anchor bolt for this scenario. And after performing an identical mesh sequence on the testing, 6 different tests, we see that it did reduce overall stress, which we will analyze here in a second. Moving on to the project's conclusion, when you take the variable mesh data from the original test and you compare it to the variable mesh data of the design that I came up with, we see that there is a reduction in max stress by about 45%. And when you research a basic material cost for a longer 2x4 and for a 1-inch bolt instead of a 3/4 inch bolt for that top pin connection, we see that it's only about $25 to implement this design, which I think is a very feasible solution. Overall, I found this project to be very interesting because it's a project that relates to something that I do every day. Thank you all very much for watching. I hope you have a good day.